we'll have a very important talk now from Mike Lisa on publishing your STAR results.
Let's see, I'm going to start off with what I think is probably the most important point, at least for me, to define kind of publication. Then I want to give a reality check within STAR anyway, although it doesn't only happen in STAR, of the time scale associated with publication. Then I'll talk about kind of how you build the components of a paper. Everybody does this differently. What I have in mind here is like a PhysRev C, but it applies to the other journals as well. And I'll tell you how you sort of build this from the inside out, at least the way that I was taught to do it, and it seems to work. I'll give sort of some tips anyway at the end, which probably is just me ranting about things, including some STAR-related points, and then we can go to the discussion. Okay, so yeah, this is just the paper itself. I assume that you and your advisor have chosen your topic and so forth. Let's see. So the main thing is we're talking about writing your paper, which is a great thing. That is our job. That is our job as scientists, to push the science forward. And this requires then truly publication. And by that, I mean the acceptance and appearance of a new scientific advance. That's something that you've used, Rick, to learn something new. You might think it's an incremental advance, and that's fine, but it's nevertheless new. And it shows up in a refereed journal. It's not your thesis or a conference proceeding or archive or cork matter talk. Those are nice. Thesis is probably required to graduate, but those are not publications. And if it needs to be distinguished, then at least within STAR, the publication goes through the whole GPC. So if you're going through a GPC for your work, then that's a publication. The main thing is here, as I said, as a young scientist, well, I mean, I would say for all of us as scientists, our job is to push the boundary of current knowledge by learning something more about HBT or polarization or V2 or something like this. And really, this is only done through publication of final results. It's very easy, sort of caught up in the moment with, a 5-year perspective, let's say, as a graduate student, to think that a preliminary result will last. It won't. It will just sort of fade away. And honestly, you will then have wasted your time and your colleagues' time and taxpayer money by generating a preliminary result, which will then fade away. Publications are what really matter. And I'll even go further, so that's me in the upper right there, to say that a student should never graduate until their result is published, means fully published. There are always special exceptions and so forth like that if somebody's mostly building a detector for their thesis or something like that, but that's not most of us. And this anyway has been my driving principle, and I would say that should be our assumption, that you don't graduate until you publish. The idea that you'll publish afterwards is always a lot of fun, but that's not true. Okay, with that sort of admonition, I suppose, out there, I'd like to go through the procedure in STAR of how to write a paper. I think most of you know this. This is Wrong writes this up very nicely. This was in his last report in September. But I just thought I'd mention reality here that's associated with this. So there are 9 steps. So step 0 is you generate your result, okay, V2 or something like this. And now the job is to publish it before you graduate. It's worthwhile to keep in mind the length of time. So the first thing you do, well, you've generated the result, presumably that takes on the order of years, who knows. Then you propose to the PWG by the time it's scheduled and stuff like this. And then maybe the PWG says, actually, I have a further question. So you go back. Let's say it's 3 weeks. That's a optimistic time scale, but let's just say 3 weeks. After this, it gets previewed by the PWGC, the group of conveners, upon recommendation of the PWG. This takes some time to schedule and so forth. And 8 weeks might be a typical time scale. They meet in quantum steps of, weeks or months, or I really don't know. And then their schedule gets backed up, say 8 weeks. After this, it's sent back to the PWG. 3 weeks is kind of a rapid turnaround in case the conveners came up with further questions, then you you find those or you address those back in the PWG, and then we're at the godparent committee. So this takes a little while to form, and then it takes a little while to go through the steps. Here we're talking about between about 8 and 40 weeks, let's say 15. So I took some data from this XML page there that the physics analysis coordinators put together. I think I started it when I was PAC a long time ago. This is only data since 2010, so we're not looking at, antique stuff here. And it's peaking just around 15 weeks, 14, 15 weeks. So, naturally, if you took an average, it would even be larger than that because of the skew. But let's just look at the peak. That's on the order of about 14, 15 weeks. The x-axis is in days. Okay, so that's important to keep in mind. After this, we go to collaboration review, which, the collaboration has 2 weeks and then 2 weeks to respond and then 2 weeks. So it's n times 2 weeks, where n turns out to be about 7. And once again, this is sort of seen in this spreadsheet, which has all the dates and so forth. So I just processed those in Excel, I guess. So yeah, we're looking at something like 6, 7 weeks there. After that, it's announced to, then it's announced, it's submitted to the archive. And then we have to wait for the referees from the journal to get back to us and the editors. We're looking at about 8 weeks. It can actually take quite a while, but let's say 8 weeks. Then we respond. But when we respond, we have to consult with the collaboration and make sure they like our responses. The GPC sort of mediates, and there could be some iteration. Let's say that's on the order of 12 weeks. That turns out to be what it is, because then you send it back to the journal, they send it to the referees, etc. It's important sort of as a reality check to say you're looking at more than a year here, okay? If you follow, let's say, a typical route. This isn't some kind of pessimistic route. This is how long it takes. Now, I've said that this is your main job. Your output scientifically is a paper. So that means take this into account, build it into your academic plan about when you're going to graduate and stuff like that. Or again, you're just wasting time. You're finding a V2 and throwing it away. It doesn't really matter. You might as well have the end of the computer connect to a resistor. Okay. The worst thing to hear, I must say, is I'm basically done. All I need to do is write up, because there you're looking at more than a year. And that's fine as long as one realizes this. But I sometimes think that that's not realized. And it kind of breaks my heart, because someone's done a hell of a lot of work, has a nice result, which then, just founders. I would say, in terms of advice, have your systematic errors and results in good shape before going in for that step 1. Don't beautify it too much, but have them in good shape, because sometimes I must say, when you have the first preview by the physics working group, sometimes it seems like questions are asked just to shoot the damn thing down. Like, oh, you don't have that plot in your analysis note? Okay, go back. We'll see you in a couple of weeks. So just load it up with everything. Okay, it doesn't have to be gorgeous. Also, I would say, in order to get your paper through, because I think you're seeing the timescales involved, present at the physics working group many times before proposing a paper, before that step 1. And when you get to that step 1, have a list of all those presentations on a slide when you do propose it. Again, the idea here is maybe somebody wasn't paying attention, and then they sort of wake up and kind of would like to slow down someone who's proposing a paper. Sorry, but this is how I actually think it happens. And then you have the list of times you've presented already, and maybe they'll not do that. And as I already said, load the analysis note with everything. Put all your plots in there. It doesn't have to be super organized. It's not the publication itself, because answering no to a single question, whether something's in the analysis note, that'll slow you down at least a week, and it already goes slow enough. Okay, let's talk about well, maybe, I don't know, maybe should I ask for questions, or should I just keep going? Who's the chair?
I think that it's okay to keep going, but if there are any burning questions here, let me know.
Okay, you'll speak up, because I don't see hands. Okay, very good. There we go with time scale. So I've sort of implied the importance of this particular task and the time scale associated with this particular task. How do you plan your paper? So you've got QA, systematics. Presumably you and your advisor came up with some kind of motivation, even if it's tenuous, that's okay. Now what you need to do is choose a target journal. And here, the thing you're looking for is impact, scientific impact, comprehensiveness, and timeliness. Okay, so I sort of made some plots here. I found kind of automated ways of plotting this up of all the STAR papers. And you can see we're dominated by the APS journals, Phys Rev Letters, Phys Rev D, Phys Rev C. And then we got a European one with the Physics Letters B. Some NIMS sort of sneak in there as actual published papers. And then we got miscellaneous. Okay, so most of it is really the APS journals and then Phys Letters B. Not surprisingly, there's been some evolution of the journals that STARS submitted to. We had 342, I believe, through publications. So I split it in half. So I'm taking a look at the first half here on the right with orange, and then the second half with gray. Not surprisingly that Phys Rev D sort of kicks in a little bit in the second half. That's as the SPIN program takes more of center stage, and that's very nice to see. Really, I would say that things are relatively constant, except for this increase in the European journals in Physics Letters B, which I find interesting. I don't really take any special meaning from it. I guess the kick up here in Phys Letters B corresponds to the kick down in Phys Rev Letters. I think there is a tendency, and I think it's a little bit of a shame and a little misguided, to try to put everything in Phys Rev Letters. I think that leads to worse papers. And then we get knocked down at Phys Rev Letters, and we end up going to like a secondary prize of Physics Letters B. I think that's kind of what's happening here in the gray. This is from Inspire HEP. So for whatever reason, even though you say you want published papers, it seems to get a lot of like conference proceedings and stuff like that. So that's sort of down here at the end, but this is ranked by citation. So we have 16 papers that are, they used to be called famous, but basically it just means 500 plus citations. And then the next category is 250 to 499, et cetera. If we look at the journal composition of these two categories, sure, indeed, it's dominated by PRL. So in the top 16, we have the Nuclear Physics A paper, which of course is the white paper from STAR. That's our most cited paper by far. This Nuclear Instrumentation and Methods paper on the TPC is up there too. Then we have 11 PRLs. And then, then we have the Nature paper on polarization. So it's mostly Phys Rev Letters. The same thing with the next category here on the right. That's either 5 to 1 or 10 to 1, depending on Poisson statistics, I suppose. Here on the left, it's 2 to 1. So the PRL mix dominance, let's say, goes down as I move to the left. However, I believe, in fact, I know, as I look at some of STAR's PRLs that are not up at the very top, they have much less impact than they would have had they been submitted to Phys Rev C. A lot of times I think there's something which I might call PRL fever, where usually it's an advisor decides they got to up the number of PRLs, so they take what really ought to be a more comprehensive, more complete, more detailed and physics-heavy paper and cut it up in the smallest possible piece and put it in a PRL. And it really can lead to reduced citations, which was part of the point, as well as impact. So I would suggest as students, you resist this PRL fever. I think it's an unfortunate thing. The journal you choose, of course, determines the breadth and depth of your message. And especially students who have done tremendous amount of work, something like Phys Rev C, I think, is often and maybe even usually the better way to go. No matter what, just don't make it that anything except the PRL is some kind of consolation prize or something like that. Okay, very good. So you've chosen your journal. The next thing is, if you want to think about how to write it, how to put it together, start with the plots that you want people to steal for their talks, your money plot. You want someone from Phoenix or a theorist or something like that to put your plot into their talk. If they take the data points from your plot and make their own plot, they're not going to cite you in the talk. So try to make the STAR plot the one that they actually cut and paste. That's your money plot. So you want to make it attractive. I'll admit that I am not always successful at these things, but Joey, for example, has been, and Xiao Yu has some gorgeous ones. Make it attractive so that people will steal it, and make it have a message naturally. So a lot of times that means you'll put your data on there as well as systematics from other experiments, theory lines and so forth. That's where you get your message. In fact, starting with the money plot is often a good way to make sure that you actually have a message. Okay, sometimes, in fact, it's pretty frequent, and it seems to be even a high energy physics or relativistic heavy ion thing, where it's not that uncommon to say we've measured V2 as a function of A plus minus or something like that from CME, and it seemed to increase slightly. Like that's the actual conclusion. That's not conclusion. That's just like, I don't know, you could call it a summary, I guess. So starting with the plot that you want people to steal, that will help you determine if you have a message, and it can help you sharpen and develop your message. Once you do that, write the full caption for the money plots. That's, I think, a good mechanical way to go. My advisor used to say that a paper is pretty much an extended caption for the plots, that the plots are the nucleus of the paper and most of the rest is caption. That's a little bit simplistic, but it is a good way to start. So with your money plot, write the caption. That means you're going to have to describe what are the curves. If there's other like data in there from another collaboration, you're going to have to cite them, and you'll start to get your citations going. This will sort of set the nucleus for the results and discussion. You'll sort of spill over out of the caption into results and discussion. And to first order, that is an extended caption. Right? In that regard, I agree with my thesis advisor. This results in discussion you pick up later at the end. Once you've done this, you have your results and discussion, you got to say what kind of data plots must be shown to support the money plot. So for example, if these are HBT radii, I think it's usually a very good idea to show the correlation functions themselves, spherical harmonic decompositions, or who knows, something like this. Event plane resolution, that sort of thing. So basically start with the money plots, you fill in results and discussion, and then you find what kind of data plots should be done to support it. Again, write out full captions, and that'll spill over into the analysis detail section. And once you start doing this, that will mean that you're starting to talk about detector details, because this plot was made with VZ distribution equals to that and the EPD and so forth. And then you're going to be filling in section 2 of your paper based on this spillover from the captions. For this, of course, a lot of what you do is look at previous STAR papers so you can get the references for how do you cite the EPD or whatever else. Yeah. Once you've done all of that, then write the introduction and conclusion of the paper, and if need be, revise the abstract. Okay, because then everything is laid out. You know what you want to say, and the introduction is sort of the introduction and conclusion are tightly coupled, as is the abstract, and they're built on what you've already written with these captions and so forth. Okay, good. That's almost all I want to say. I want to maybe repeat some things and maybe make some random points along the way if I didn't already say them. This is my advisor, who I think is the greatest advisor that ever walked the earth. So he was the University Distinguished Professor at Michigan State. He directed the cyclotron lab. He founded this facility for rare isotope beams, FRIB. He was a force of nature. And anything that I said, good advice in this talk came from him, and everything else just came from me. This is something that he meant from his heart, and I mean it from my heart too. Don't even bother if you're not going to publish it. It's a waste of time. He told me to love every data point. I always have to put that in when I refer to him. I didn't really talk about that. But it's nevertheless true that the last 10% of the paper takes 90% of the effort. And please build that into your plans. It's heartbreaking to see someone say, well, I have to graduate because, I don't know, there's a deadline or something like that. Put it into your plan. All I have to do is write it up. That's something I always hate to hear. Do have a physics message to your paper. When you're making your money plot, think about who's going to steal this thing and make it really nice so they steal it. And then think about what they're going to say. Like, what's the bullet point on the slide going to say once they've stolen your figure? surprising to me, at the higher energies in nuclear physics, I came from lower energies. This sometimes can be missing. Don't obsess over PRL. PRC can have a larger impact. It can be quicker, and I think always running to PRL has led to mistakes. I've sort of gone through a procedure. That's not the procedure, but a procedure of how to write a paper. The figures are the nucleus of the paper, build up from the money plot, captions, results. That tells you what support plot, captions, results, and that will lead naturally to the experimental details. And at the end, you take care of the physics message. Finally, this is something that was very relevant when we were writing papers, my advisor and I, because it was much lower energies. People were used to being in groups of 2 or 3, kind of an advisor with 1 or 2 students, but nuclear physics was starting to get more collaborative, and people were not used to writing papers collaboratively. What my advisor advised, and I think this has served me very well, is just if your collaborator in STAR or outside of STAR wants to make a change to the paper, a wording thing, you know, unless it's legit wrong, like it would totally screw it up, just do it. Okay, they're your collaborator. They probably have a good reason. If it doesn't hurt anything, even though you'd rather it to be a different way, just do it. The whole process takes long enough, and you don't need to be making enemies, I would say. Okay, the ones that Conrad didn't say because they were STAR specific, fill up that analysis note with everything you can think of and present at PWG meetings before you propose the paper. That'll just reduce delays in an already long process. Okay, that's all my slides.
Thanks for the great advice. I guess one question that I have is, when you write the introduction part, how do you gather all the sources? Like when the first sentence you say like the QGP is a strongly interacting matter, and then you have parenthesis 1-6, and where do you gather those sources?
Yeah, someone else already did that in the previous paper. No, I mean, that's a good question because, you know, we don't always want to just even be self-plagiarizing. It's good to start from a review. So if you are writing a polarization paper, we wrote a very nice review which has 600 references in it and so forth. I would say make this at the end. Hopefully somewhere in your paper, or maybe somewhere in your paper, you've compared with theory, like in the money plot, for example, and that paper would naturally then be cited. It's claiming a particular phenomenon, so that could be cited at the very beginning. And then, especially if it's a theorist, they've cited themselves quite a few times. So that's kind of how it builds up, either from a review paper or from, you're trying to make connection with the broader context anyway. Hopefully some theory, maybe some Hades experiment or whatever else, and you'll cite them and then look what's in what they're citing, and that's sort of how it builds.
Okay, thank you.
Hi, Mike. Yeah, really nice suggestion. So I have actually a question about like just choosing, you know, the theory comparisons for like your money plot. Yeah, so I mean, it definitely doesn't like speak to every single paper, but like how many like of them is probably like a preferred value of this is the, you know, number of like theory plots that I'm comparing it against, compare my result against, that kind of thing. Yeah.
Yeah, that's a good question. I never really I never really saw it where we're like, oh my God, that's too many. Usually usually it takes some effort really for the theorist to give us something to compare to. I mean, for example, Joey with the polarization paper contacted a number of theorists, and they were willing to various degrees to be compared to the data with this cut and that cut, and well, don't take this seriously and that sort of thing. Honestly, I don't know that there's an upper limit. So I'm not giving you much of an answer. I would, as soon as you start thinking, oh my God, that's too many theories, I just never saw that happen before.
Okay, so the advice is as many as you can, right?
Yeah, I would actually say so. That's going to make your paper get a lot more citations, and it's also going to give you a message. You know, this particular phenomenon was assumed in the three fluid hydro, and it actually explains the data better than than URQMD, which is supposed to apply better at low energies where things are hadronic. And that now becomes an interesting story because you're comparing to more than one theory. Yeah, that helps you develop your physics message.
All right, thank you.
Hi, thanks again for the nice advice. During the timeline you gave out, it seems like there's a lot of periods where you're waiting for responses. Would you say are the most like active periods of writing a paper, and what are the most passive, so that you could like plan doing other stuff alongside it?
That's a good question. Let me take a look at that 9-step business here. In all cases, there's a lot of hurry up and wait. I think the main thing is in GPC deliberation, it's probably important to be as active as possible. First of all, if they come back with a set of questions and you wait a week before answering, well, there goes a week. But you know what else? That also is a signal like, okay, don't worry. I mean, they'll take longer next time. Okay, so that's the time when you want to be as active as possible as during the GPC. It will require like sudden activity, wait, sudden activity, wait. There are certainly people in that room who can give very recent advice on that. If I think about, in all cases, it's a lot of waiting. And all I can say is when it's your turn to respond, the quicker you do it, it's a nonlinear effect. If you respond quicker, then so will they respond quicker. It's not only the extra time that you didn't take. I don't know if I identify one. Maybe someone else has something to say about that. I'll put back on the screen those 9 steps. So maybe somebody has an idea about that. I don't know if Joey does, maybe. So which one of these is the most active, according to people who've recently gone through it?
I think up to the point the GPC is formed until, probably step 4, I think that's the area you probably will be writing the paper and doing analysis, doing all the checks most actively. That's really the place I think you really spend your time to write the paper, the analysis note, and do all the comments. In the GPC, as Mike commented, the GPC members have their own schedules. They usually, when you send out something, they should give you a response in 1 or 2 weeks, things like that. But so there's a lot of waiting. I would think, and that also back to the corporate media review, the journal review, there's a lot of waiting happening. So that's probably the time you can do something else. But in the GPC, one kind of suggestion from me is, as also Mike commented, you need to be active. If you are active, if you respond very quickly, you will naturally have some pressure on the GPC members for them to kind of come back to you quickly. If you are very kind of laid back, say, okay, I respond in 3-4 weeks, then the GPC members, well, okay, so if you are slow, then probably doesn't matter if I also be slow, put something at higher priority, I think.
Hey, Mike, thanks for a great talk. I think a lot of us are going to make use of it. So I guess, something that's not in your timeline here, but I guess just looking forward, for maybe some students or people who are becoming postdocs, at what point in here in your experience do you think it becomes not crazy to start thinking about starting this process again for another paper? And if you think that might be inappropriate to do so the first time around, what sort of advice could you give to students to sort of like get over the post-paper blues and start the process over again?
Yeah, if you have something new to say, I would say there's no reason not to get on it. I must say, once someone survived this gauntlet, let's say, I don't know if they have blues or if they kind of feel kind of triumphant and write another paper. One person sitting in the room right now is Joey Adams. He pushed through the 3 GeV one, and now he's well along anyway into the 27 GeV. I don't think you have to wait or something like that or pause. If you're kind of going at high octane, keep it up. Easy for a professor to say.
I have a question regarding to the money plot. So if the result is currently not supported by any theory, or the theory is still being built up or explored, so how we can write up to make it attractive to the people for the paper?
So I guess there's a couple things. It could be that your results, there is no theory to compare them to. And I think an example of this or the theory is so woefully inadequate that any comparison is almost performative. And I think an example of this is, for example, the V1 analysis of Xiaoyu, I'm sorry. There, one would really like to compare to three-dimensional viscous hydro with baryon currents, but the predictions are hard to generate, apparently, at very forward rapidity. So one is stuck then comparing to URQMD, where you know you're going to fail. Nevertheless, there is a good in-principle connection to baryon stopping when you take a look at forward dynamics. Baryon stopping, which is sort of an equation of state effect, very forward change in the momentum. That's exactly what leads to baryon doping at mid rapidity, and that's kind of the entire point of the beam energy scan. So it's important to understand that process. The problem is the theory is simply not up to it's not ready to use the data to constrain that process. In that case, one makes a lot of in-principle statements that this in principle is sensitive to the process, which should be compared with sophisticated hydro models, et cetera. And then we'll put in URQMB because that's almost the only thing that one really can do. That if that's what one does, it's fine. I mean, you're making a strong in principle connection. There's also the example like the meson spin alignment, which is wildly in contradiction with every theory, except, unfortunately, a theory that is hyper-tuned to predict exactly that one measurement and has an infinite number of free parameters. In that case, it's a matter of taste. If one really believes in the experimental result, then one can put it up there as an enigma. And I would actually compare with regular theories, let's say, or conventional theories, and hold it up as an enigma, as a puzzle. Or one could push very hard on this alternate, rather new, novel physics phenomenon that explains the effect, or at least, I don't know about explains, but anyways, consistent with the effect. If there really is an observation that has no relevant theory at all, even speculative, I would say, why'd you do it for? There really ought to be something, even if it does a poor job, it really ought to be something. I'm not sure if I answered your question.
Okay, yeah, that's why it's a pretty broad topic, and everyone have every issues. Yes, pretty good to know your answer.
Hello, Mike. So you rightly brought up the point regarding the money plot and how that would, the theorists would take care and work on it. But what about an alternative where we also put some of our data points out there, like maybe use Rivet once the paper has been published and put up the data on Rivet? That would also encourage the theorists to take up those data points and maybe run their generators or simulations on it.
Yeah, I'm not a big fan of Rivet. I'm also not a big expert on Rivet, so it's possible I could be converted. I mean, a lot of what we did was HBT and polarization, of course. And honestly, if you don't understand the detector quite well, then releasing data points is, I would even say, irresponsible, honestly. It's like handing a kid a box of matches. They'll do something with it. So if for very high level things, V2 or something like this, versus PT, fine. If I would want to upload, for example, the full 3-dimensional or even in principle 6-dimensional pion-pion correlation function that we're doing femtoscopy on, I think I'm just asking for trouble. The theorist will do something, and suddenly that will become the star result because it was based on these data points. So is there a particular example that you have in mind? Because I think a lot of it corresponds to the discomfort I would have is how high a level is it that you want to release? Would you like to, for example, release ST tracks? What do you think?
It was the final data points, but yes, to be fair, I didn't think about the disadvantages, but now that you bring it up, that yeah, definitely makes sense.
The final data points that's fine, but I think that Rivet, at least as I've heard it described sometimes, let me put it simplistically, I've heard theorists ask for a list of 4 vectors. As soon as you hear this, you're like, oh my God, anyone who asks for something like that can definitely not have a list of 4 vectors. What could possibly go wrong? So, but if it's high level points like V2 is a function of PT, yeah, sounds good. I don't know if you need Rivet for that, but sounds good.
Thank you.
If I may comment on this, it's Maria from Zoom. So about the Rivet. So for Rivet, we use only the HEP data points, so nothing extra. So this is already published, like when we publish our data and we make them like available for everyone, and we upload them to the HEP data webpage, and Rivet is using these data points, so nothing more than this. So all the other like requests from theories is just not really related to the Rivet itself. Just a comment.
That's good. I mean, that to me makes a lot of sense. I mean, it could be Rivet, it could be, anything at all. There, at some point early on, was the discussion that this would make sort of data analysis experiment independent almost, like it's not STAR, it's not Phoenix or something. Everyone could run a generic analysis on this data that's provided in Rivet. And as an HBT person, I mean, that was a total non-starter. But yeah, if it's things like the data points that are already on the plots, that sounds pretty good.
So if I may again, Maria again. So with HBT, I don't know what is the status now for Rivet, but the most complicated part is the event mixing there. Maybe not the most, but it was one of the very difficult points to move forward with. So I don't think HBT is even possible to do there, but this is just a comment. But I understand what you mean, that you just forget about the source of this analysis, and you don't even need to read the paper, just take the analysis which is available there, because there is a code should be written there. You take the data points and then you go with your model. But this is generally kind of an idea that it's so available for everyone. But of course, it's like pros and cons. So yeah.
Yeah,
I understand what you mean.
I would even say that, the event mixing, of course, is an issue, but as are the 2-track cuts. And anyone who's who's managed to follow all the complicated acceptance effects in Joey Adams's 3GeV polarization analysis, I mean, this would knock a theorist on their butt if they thought about it, which they wouldn't. And then they would get some result which has a passing resemblance to the data. For much of what we do, the real trivial stuff is trivial, but for much of what we do, you really do need to understand the data itself. And I think that doesn't lend itself to some generic analysis to make it available to the world. It's not like the Hubble telescope where they post the images and anyone can do anything they want. This requires expertise and knowledge.
Let's thank Mike again.